This morning at 5:21 a.m., the largest earthquake recorded in the Texas Panhandle in over a century struck Roberts County, about 24 miles southeast of Miami, Texas, a magnitude 5. 0 that the USGS measured at just 3, 5 miles below the surface. People were asleep in ranch houses across cattle country when the ground started moving beneath them. The shaking was felt across much of the Texas Panhandle, including Amarillo, and reached as far as Oklahoma City and Tulsa, Oklahoma. Residents also reported feeling the earthquake in parts of New Mexico. In Pampa, several residents said the shaking lasted as long as 30 seconds. Texas is not supposed to shake like this. That is the unanimous reaction from the scientific community this morning. And it is also where the story gets genuinely strange. Because what is sitting underneath the Texas Panhandle, and why it just moved, has 4 completely different scientific explanations, none of which researchers have ruled out yet. And the deepest one connects this flat wheat field country to one of the most violent earthquake sequences in American history. Let's start with what actually happened this morning, because even the basic facts are generating disagreement. The USGS initially classified the earthquake as a magnitude 5. 0, though measurements can be revised as scientists review additional data. Some outlets are measuring it slightly higher. USGS records indicate it was the strongest earthquake recorded in the region since at least 1900, and only the 4th magnitude 4.0 or greater earthquake recorded in the Panhandle during that period. But here is where the contradiction lives. An older National Weather Service historical compilation estimates that earthquakes near Panhandle in 1925 and Dalhart in 1948 had magnitudes of 5, 4, and 5.2, respectively. So, which is it? The strongest ever recorded, or not quite? The honest answer is that it depends on what you mean by recorded. The historical numbers from 1925 and 1948 were not measured by seismographs. There were none out there. Scientists sized up those earthquakes by mapping where people felt the shaking and where damage appeared, reconstructing events from letters, newspaper accounts, cracked plaster, and old buildings. Those are estimates built from human memory. This morning's 5.0 came from actual instruments reading ground motion in real time. When media outlets call today's event the strongest ever recorded, they likely mean the strongest ever measured by an instrument, not the strongest ever to occur there. The distinction matters because it means the seismic history of the Texas Panhandle is considerably blurrier than the morning's headlines suggest. We are comparing a photograph to a hand-drawn sketch and asking which one is more accurate. What makes this morning's event genuinely unusual, beyond the magnitude itself, is the depth. The quake's epicenter was pinpointed at a shallow depth of just 3-5 miles, which contributed to the tremor being felt across a broad area. When a rupture happens close to the surface, there is almost no rock between the breaking point and the ground above it to absorb the seismic energy. That is why the USGS assessed the quake with a maximum intensity of V6 on the shake map scale, while many individuals who reported the event described experiencing an intensity of up to 7. Some residents near Amarillo reported feeling shaking almost 400 kilometers from where the ground was actually breaking. People in the small town of Pampa described being jolted awake by a sound like rolling thunder, except the thunder was coming from beneath them rather than from the sky. Local media reported that this was the strongest earthquake recorded in the Texas Panhandle in more than 100 years, and only the 4th such event of magnitude 4. 0 or greater documented in the region since 1900. As of Thursday afternoon, no major damage or injuries have been reported. The USGS damage model came back with green alerts across the board, which reflects the fact that Roberts County is genuinely remote. Miami, Texas, unrelated to the Florida city of the same name, is the seat of Roberts County, one of the state's least populated areas. The 2020 census lists the county's population at just 827. No casualties, no collapsed buildings, no economic catastrophe. But within hours of the event, seismologists across 3 states were paying very close attention to a corner of Texas that most of them rarely think about. Now, the most important question: what actually caused the ground to move this morning? There are 4 competing explanations, and scientists have not fully ruled out any of them. The first explanation is the one most scientists consider the leading natural candidate. An ancient geological scar just woke up. Geologists have traced a fault system beneath the Texas Panhandle to something called the Amarillo-Wichita Uplift, the buried remains of a rift where the North American continent attempted to tear itself apart roughly 500 million years ago during the early Cambrian period, and failed. This was long before dinosaurs, long before anything with a spine was crawling on land. That failed rift is not some recent discovery. It has been sitting there, known to geologists, buried under the wheat fields and cattle ranches of the Panhandle, mostly silent for hundreds of millions of years at a stretch. The leading natural theory is that tectonic stress builds slowly across the entire continent, and every few decades finds the weakest point in the crust and releases there. In the Panhandle, that weak point is the old failed rift, no human activity required. Just geology doing what geology does on a time scale that makes human civilization look like a brief flash of light. A National Weather Service meteorologist in Amarillo said the earthquake originated from northwest Roberts County and confirmed that there are some minor fault lines in the Texas Panhandle that could cause weak to moderate earthquakes. He added that smaller earthquakes have occurred in the region within the past year or two, that they do happen there, just not frequently. The second explanation involves something that almost nobody is talking about this morning: old oil fields from decades past. Several historical Panhandle earthquakes in 1936, 1966, 1974, and 1980 happened directly on top of major petroleum fields that were active at the time. Researchers who studied those events suggested they may have been triggered by the old oil production activity. But the evidence is genuinely uncertain, and here is why. The instruments of that era could not pin down depth or location with anything close to the precision available today. Depth is one of the most consequential measurements in seismology because it determines whether a rupture is on the interface between plates or deep inside the descending rock. Without reliable depth data from the historical record, connecting those mid-century events to surface drilling operations remains an open question rather than a settled one. The third explanation is the one that immediately jumps to most people's minds when they hear Texas and earthquake in the same sentence: modern wastewater injection from hydraulic fracturing. This is a real and documented phenomenon. Oklahoma has extensive documented cases. Parts of West Texas have documented cases. When the leftover fluid from oil drilling operations is pumped deep underground, it can measurably trigger earthquakes on nearby fault lines by reducing the friction that holds those faults in place. A study published by the American Association of Petroleum Geologists bulletin noted a sustained rise in earthquakes, measuring 2.5 or higher in the region over the past decade. But officials responding to this specific event this morning were notably cautious, saying plainly that more data is needed before anyone can draw that connection here. The reason for that caution is the magnitude itself. A 5.0 to 5.1 is considerably high for a fracking-induced event. Hydraulic fracturing typically induces microearthquakes with magnitudes under 1.0, which are imperceptible to humans. Induced events can reach higher magnitudes when drilling operations intersect with pre-existing faults, but the scale of this morning's event puts it at the upper boundary of what fracking has been documented to produce anywhere. It is unclear what caused the earthquake in the Panhandle, the National Weather Service meteorologist in Amarillo stated. That brings us directly to the fourth explanation, which is also the most honest one, and probably the most accurate thing said about this event today. Nobody knows yet. Within hours of the quake, scientists quoted across media coverage were saying exactly that. Determining the cause takes time, data, and careful modeling, and that tectonic stress can simply reactivate ancient faults on its own with zero contribution from anything happening on the surface. In science, we do not know yet is not a failure. It is the accurate sentence when the accurate sentence is, we do not know yet. But here is the detail that should actually stop you. The geological structure sitting underneath the Texas Panhandle, that half-billion-year-old buried failed rift, is structurally similar to something called the Reelfoot Rift. That name may not be familiar, but the region above it certainly is. The Reelfoot Rift is the same kind of failed buried rift system sitting underneath the New Madrid Seismic Zone where Missouri, Arkansas, and Tennessee converge. The New Madrid seismic zone is responsible for the earthquakes of 1811 and 1812, a sequence so powerful that contemporary accounts describe the Mississippi River appearing to briefly reverse its flow direction. The shaking was felt from Canada to the Gulf of Mexico. It remains one of the most violent earthquake sequences in recorded North American history, and it occurred not on the west coast, not along a dramatic mountain range, but in the flat interior of the continent, sitting above an ancient failed rift that had been quiet for millions of years before it suddenly wasn't. No scientist today is predicting that Texas is due for a repeat of that sequence. Nobody is forecasting a catastrophic event. What geologists who study the Amarillo-Wichita uplift are pointing out is narrower and more interesting than a prediction. The geological recipe in both places is essentially the same. Old failed rift, buried deep, quiet for hundreds of millions of years. Continental stress, finding it again. One happens to sit under the Mississippi River Valley. The other sits under Texas wheat fields and cattle ranches. The ingredients are identical. The outcomes so far have been very different. Whether that difference is permanent or simply a matter of time and accumulated stress is not a question anyone can answer today. USGS records indicate the earthquake struck at 5:21 a.m. MT on Thursday, July 23, 2026, near Miami, Texas, at a shallow depth of 5.5 kilometers. The USGS ran its aftershock forecast within hours of the event. The probability of another event of similar or greater magnitude in the coming days is small, but not zero. A second smaller event followed the same day, hundreds of miles south near Westbrook. An unrelated event, but one that contributed to the sense among regional seismologists that Texas is producing more notable seismic activity in 2026 than in any recent comparable period. The historical record for the Panhandle specifically shows roughly 4 earthquakes at or above magnitude 4.5 since 1900, with the previous events arriving in 1925, 1948, and 1974, push from a 5.0 to a 5.5, and the historical frequency drops to roughly once every 50 to 100 years. Push to a 6.0, and you are in territory of a once in 3 centuries event for this region. This morning's 5.0 is not a statistical freak. It is something closer to a clock finally striking an hour it was always going to strike. The ground doing something that the geology beneath it was always capable of doing, on a schedule that no instrument built by humans can reliably predict. What Texas woke up to this morning is not impossible. It is not unprecedented in the full geological sense of that word. It is something that was in preparation before Texas existed as a concept, written into the structure of the crust 500 million years ago when the continent failed to tear itself apart and left a scar that has not fully healed since. The instruments that measure these events get better every decade. The ancient geology underneath the Panhandle does not change. The two are going to keep meeting, and this morning's 5:21 a.m. event is the latest moment where they did.